Yeah, well, so I've argued that the universe is effectively a quantum computer. In fact, not even effectively, actually is a quantum computer. And actually, this is something, in some sense, it shouldn't be controversial because, first of all, we know that the laws of physics support computation. We know this. We don't have to prove it because I actually possess a computer, right? And then we actually also know that the laws of physics support quantum computation, so computation at the most microscopic level performed by elementary particles. And again, I don't have to prove it because I own a quantum computer, right? And here at IQC, you have vast laboratory space chock full of quantum computers. So, the fact that the universe at bottom is processing information, computing in a uniquely quantum mechanical way is in some sense uncontroversial. Though when I make this argument, it always seems to cause controversy, so I don't know why this is so. But yeah, so in fact, when we're building quantum computers, it's not like we're starting from scratch and saying, oh, we have these darn quanta and they're not computing, they can't do anything, let's make them compute. That's not the way it works. It's more that the universe itself is already processing information at this microscopic level all the time. And when we build a quantum computer, we're just kind of coming in and hijacking the ongoing computation to make it compute something that we would like it to compute rather than what it would normally be computing. So yes, so I mean, I think that, if you like to think of yourself when you're building a quantum computer as simply, participating in the larger computation in a productive way, I think that's a sort of nicer way to think than saying we're going to force the universe to compute at a microscopic level. We're participating in the universal computation rather than forcing the universe to compute.